So this is a problem which I have given for you in the internals, and this is a Nonsway frame. Why it is called as Nonsway frame? Because a sway at a column is prevented by the column, which is prevented by the fixed support at the beam level. So that's why it is called as a non-sway frame. So first step, we'll start with the fixed end moments. So first step is the fixed end moments. So we'll calculate the fixed end moments of all the members. So first one, MFAB. So it is a UDL. So we know if we have a UDL, so formula is WL square by 12. So we'll substitute 30 into 4 square by 12. So you will get the answer as 40 kilonewton meter. So next, minus MFBC, which is equal to, so it is a 2-point loading, so you have to consider one concentrated load at a time. So 30 into, it is PAB square by L square, the formula is, so 30 into, for the first 30 kilonewton load, A is 2 meter and B is 4 meter, so PAB square by L square, plus for the second 30 kilonewton load, A will be 4 meter and B will be 2 meter, so 30 into PAB square by L square. So if you solve, you will get 30 into 2 into 4 square plus 30 into 4 into 2 square divided by 36. So you will get 40 kilonewton meter. So next, MFCB, since you have a same concentrated load 30 kilonewton and the distances are also same, so you will get the same answer as 40 kilonewton meter. So next is MFBT. So as I already told in the class, for the fixed end moments, especially for the columns, you have to view in the opposite direction of the load. So when you view in the opposite direction of the load, so this will become left hand and this will become right hand. So MFBD will be negative, and the formula for that is W into L by 8. So if you solve, you will get 30 kilonewton meter. Similarly, MFDB will be plus 30 kilonewton meter. So this is a fixed end moments. Once again I am repeating, especially for the columns you have to take care. Whenever you are taking the fixed end moments for the column, you have to view in the opposite direction of the load. So load is acting towards left, you have to view it in the right direction. When you view it in the right direction, left hand, that is MFBD will become negative and MFDB will become positive. So this is the first step, which is very important step, fixed end moments. So we'll move on to the second step. So second step is slope deflection equation. Slope deflection equation. So first is MAB. So we know the formula, MAB is equal to MFAB plus 2EI by L into 2 times theta A plus theta B minus 3 delta by L. So this is the formula and we have derived this formula. So MAB is equal to MFAB. MFAB, the value for MFAB is minus 40. So minus 40 plus 2E. I value in the problem it is given as 2I. So in the place of I you have to substitute the value of 2I. So 2E into 2I, and the value of L is 4 meter, into theta A is equal to 0. Why it is equal to 0? Because you have a fixed end at A. So when you have a fixed end at A, it will not allow any rotation or translation. So theta A is 0, theta B, and since this is a Nonsway frame, delta also will be equal to 0. So it will be only theta B. So minus 40 plus EI theta B. I'll call this as equation 1. So next is MBA. On the same lines of the slope deflection equation, we'll write the equation. MBA is equal to MFBA. MFBA value is equal to 40 kilonewton. So MFBA is 40. So 2E, and the value of I is 2I, and the value of L is 4. So 2 times theta B plus theta A minus 3 delta by L. As already explained, theta A will be 0 and delta also will be equal to 0. So 40 plus 8 EI by 4. So you will get 2 EI theta B. I'll call this as equation 2. Next is MBC. So MFBC is minus 40. So minus 40 plus 2E into the value of I given in the problem is 1.5 I. So in the place of I you have to substitute 1.5 I divided by 6. 2 times theta B plus theta C minus 3 delta by L. So in this case both theta B and theta C are not equal to 0. Why? Because you will be having theta B here. Since this is rigid joint, you will get theta B, and since this is a hinge support, you will get the rotation. So theta B and theta C will be there, but delta will be equal to 0 since this is a Nonsway frame. So minus 40 plus, so you will get 2 into 1.5 into 2 divided by 6. So you will get EI theta B plus 2 into 1.5 divided by 6. You will get 0.5 EI theta C. I'll call this as equation 3. So next is MCB. So MCB is MFCB. MFCB value is plus 40. So 40 plus 2E. I value is 1.5 I for the same beam. So it is 6. Then 2 times theta C plus theta B minus 3 delta by L. Here also delta is equal to 0 since this is a Nonsway frame. Both theta C and theta B will be there as already explained. 40 plus EI theta C plus 0.5 EI theta B. I'll call this as equation 4. Next, MBD. So MBD is equal to MFBD. MFBD is minus 30 kilonewton meter. I have already explained how you got minus sign. So minus 30 plus 2E. The value of I is given as in the problem as 1. Even if they don't give the value of I, it is considered as 1 only. So 2EI by 4 into 2 times theta B plus theta D minus 3 delta by L. So in this case delta L, as usual, it is equal to 0. Whereas D, you have a fixed support. When you have a fixed support, as already mentioned, you will not get any rotation or translation. So even theta D is also equal to 0. So you will get minus 30 plus EI theta B. So I will call this as equation 5. Next, MdB will be equal to plus 30 plus 2EI by 4, 2 times theta D plus theta B minus 3 delta by L. So here theta D is also equal to 0 and delta is also equal to 0. So we will get 30 plus 0.5 EI theta B. I will call this as equation 6. So this is the slope deflection equation. So next we'll move on to the third step, very important step, joint equilibrium equation. Joint equilibrium equation. So you have to see the support condition of the problem. So you have A, B, C and D. So A and D are fixed support, so no need to balance that because it is already in equilibrium. The two joints which is not in equilibrium are B and C, because B is a rigid joint and C is having a hinge support. So B and C is not in equilibrium. So we have to see that what are the members which is passing through B. So from B we have three members. One is BA, BC and BD. So we need to consider moment at BA plus BC plus MBD equals 0. Equilibrium means it should be balanced or it should be equal to 0. So ultimately whatever the moment that is getting from joint B should be equal to 0. So from B you have three members, BA, BC and BD. So all the three should be equal to 0. Next, the other joint which is not in equilibrium is joint C, because you have a hinge support. So the only member which is passing from joint C is CB. So MCB should be equal to 0. So this will be the two joint equilibrium conditions. So we will find the equation for these two. So first one is MBA plus MBC plus MBD equals 0. If you solve these three equations, MBA, MBC and MBD, you will get the answer as so here you have 2EI theta B plus EI theta B plus EI theta B. So from the first you will get 4EI theta B. Next here you have 0.5 EI theta C, so plus 0.5 EI theta C. Next 40 and minus 40 will get cancelled, so you will have minus 30. If you take to the other side it will be plus 30. So next is MCB is equal to 0. So moment at CB is equal to 0. So you have 0.5 EI theta B plus EI theta C is equal to minus 40. So these are the two joint equilibrium equations. So if you solve simultaneous equation using your calculator, so equation, two unknowns, 4.5, 30.5, 1 minus 40. So theta B you will get 13 point EI, whereas theta C you will get minus 46.66 EI. So you have got two unknowns. So theta B is 13.33 by EI and theta C is minus 46.66 by EI. So you need to substitute. Since I have to turn the page, I am writing it here only. So substitute theta B and theta C in slow deflection equations. We'll substitute all the values of the unknowns starting from MAB. So I'm writing it here only, the answers. Minus 40 plus EI theta B. EI theta B is 13.33. So we'll get the answer minus 26.67. Next MBA. So this is MAB. Next is MBA. MBA is 40 plus 2 into 13.33. So we'll get the answer 66.66. Then next MBC, 40 plus EI theta B. EI theta B is 13.33 plus 0.5 into EI theta C. Theta C is minus 46.66. So we'll get the answer as BC. You will get it, the answer as 30 kilonewton meter. Next is MCB. MCB is 40 plus EI theta C. EI theta C value is minus 46.66 plus 0.5 EI theta B. So EI theta B is 13.33. So it is 0. Why you have to got 0? Because at CB you have a hinge support. Hinge does not resist any moment. So that's why MCB is equal to, it should be equal to 0. So next MBD. MBD you have minus 30 plus EI theta B, minus 30 plus 13.33. So minus 16.67. Next 30 plus 0.5 EI theta B. So for MDB you have 36.66. So we'll check the value once again. So MBC will check the value, minus 40 plus EI theta B 13.33 plus 0.5 minus 46.66. So please make a correction here. It is minus 50. So these are the final end moments and all the units are in kilonewton meter. So I have not written all the values individually. Here all the values are in kilonewton meter. Next we'll write the bending moment. So we'll write the value of all the forces first. So MAB is equal to minus 26.67 MBA equals 66.67, MBC equals minus 50, MCB is equal to 0 and MBD is minus 16.67 and MDB is equal to 36.67. So first we'll write the moment diagram. So AB, BA, BC, CB, BD and DB. So AB is minus 26.67. Minus means it is anti-clockwise. The shortcut for this is the arrow should face the length of the member. So it will be a shortcut for you to easily write the bending moment diagram. So anti-clockwise. MBA is clockwise 66.67. MBC is minus 50 anti-clockwise and this is 0. And MBD is minus 16.67. So it is anti-clockwise. And MDB is 36.67. It is clockwise. So if you write this diagram, it will be easy for you to write the bending moment diagram. So we will write the bending moment diagram here. Okay, so here you can observe both these are hogging moments. So it tends the beam to move upwards. So both these are hogging moments. So first value is minus 26.67 and minus 26.67 and MBA is 66.67. We'll join these two values. Next, MBC you are having minus 50. So it is also a hogging moment. It tends the beam to move upwards. It is a hogging moment. So 66.67 and you have 50. So 50 somewhere it comes over here, or you can take it up since you are not writing to the scale. So 50. So and MCB was equal to 0. So this will be joined here. So this value is 50. Okay. So next we have come to the column. So here also you have to view in this direction because your load was acting towards left. So you have to view opposite to that. It is opposite to that, and you can observe these two are also a hogging moment. It tends the column to move towards right. It is a hogging moment. So MBD is minus MDB is 36. So here I'll write 16.67 and this one is 36.67. I'll join these 2 points. So now we have written the moment diagram. Now the another one which is left is the loading diagram. Here bending moment diagram consists of 2. One is end moment diagram which is end moments diagram, and the second one simply supported beam with the load. Why we are considering separately? Because we have already written the moment diagram due to the end moments which we have got. The another one which is left is simply supported with the load. So here first one is you have a UDL, we are having a simply supported. The maximum bending moment is WL square by 8. So if you solve WL square by 8, so we'll get 30 into 4 square by 8. Don't get confused with the end moments and the fixed end moments. Fixed end moments is will be getting due to the load, due to the external load acting on the beam. End moments you will get it at the center of the span due to the maximum bending moment. 30 into 4 square divided by 8, you will get 60 kilonewton meter. So 60 kilonewton meter, and we know that the shape of the bending moment diagram for the UDL is parabolic, and this value is 60. And next we have a two concentrated load. Since the load are same, the reaction that you get it from the two supports are also 30 kilonewton. So at this point 30 into 2 60, and from this point also 30 into 2 60. So you will get a trapezoidal shape. 60 60 and 60. Next we have a concentrated load acting at the center, and if you take a simply support with concentrated load acting at the center, the maximum bending moment formula is WL by 4. So 60 into length of the column was 4 meter by 4, you will get 60 kilonewton meter. So we know that the shape of the maximum bending moment for the concentrated load acting at the center is triangle. So it is 60 kilonewton meter. So the hogging moments will be negative, and the part of it will be inclined, will be inscribed is also negative, and the part of the moment which is outscribed will be the moment which is sagging, it is positive, and the moments which are hogging are negative. So this is the analysis of the Nonsway frame using slope deflection method. Thank you.